Today we are going to discuss types of electrical elements and parts of a circuit. Linear elements. An element is said to be linear if the input or excitation and the output or response current follow a linear relation, that is, any change in input produces a corresponding change in output given by the linear equation y equal to mx. Its name implies that the input and output relationship should be a linear. Here y equal to mx is the equation of a straight line and passing through the origin. Here the current versus voltage graph is plotted, which is a straight line and it is passing through the origin. If we observe the curve, then from 0 to V1 and V1 to V2, V2 to V3 are increases with same proportion. So this gap, this voltage magnitude is equals to this, the difference of V2 and V1, and the difference is equals to V3 and V2, all are same. And we can see in this graph, the change of the graph from 0 to I1, I1 to I2, I2 to I3, all are these gaps are same. That means the slope is constant. So that type of element, the element due to the application of input voltage, if the current or response of that element increases linearly or with the same slope, a constant slope, that element is called the linear element. Any circuit containing the linear elements is called the linear circuit. Now we'll discuss the properties of linear elements. Linear elements obey Ohm's law. We got from Ohm's law V is equals to IR relationship. Here current and voltage both are having with the linear proportion when the resistance R is the constant, where R is the proportionality constant. So here also we can see as it increases linearly, and these characteristics is same as the Ohm's law characteristics. So linear elements obey the Ohm's law. The voltage current relation is linear. The voltage current graph is straight. Linear elements obey the superposition theorem. We'll discuss in another video about the superposition theorem. The current flow through the linear elements will be uniform. Whatever current is flowing through an element, that will conduct through that element uniformly. Now the application and uses of linear elements. Before that, I am telling you the examples of linear elements are resistor, inductor, capacitor. The property of these elements to oppose the flow of current, or the inductor, capacitor, they have the capability to store the energy or to convert the electrical energy into another form. So the linear elements are used for current limiting, filtering, energy storing, and energy conversion applications. Now, nonlinear elements. So from here we can say the element which does not obey the linear element properties, those elements are called nonlinear elements. In linear elements, we have seen the voltage and current relationship should be a linear or a straight line. But in nonlinear elements, the voltage current relationship is non-linear. Here it is a graph due to the change of voltages from 0 to V1, V1 to V2, V2 to V3, all are equidistant. But here if we see in the y-axis, 0 to I1, I1 to I2, and I2 to I3, these differences are not equal. So from here we can say this is not here the proportionality constant is not the same, and it is not a linear graph, and The best example of nonlinear elements is the diode, and any semiconductor or power electronic devices such as BJT, field effect transistors, these are the examples of nonlinear elements. So if we see this graph, this is the characteristics graph of transistor. Here the graph showing the voltage and current relationship. This is not a linear in nature. This side we have taken the voltage, and about the y-axis we have taken the current. So this has no linear relationship. This is the characteristics graph of characteristics graph of diode. So these also not a linear. It is not increases with a same proportion. Nonlinear elements properties already I discussed. Which does not obey the linear properties, that is the nonlinear elements. And application of nonlinear element and uses of nonlinear elements. The main function of nonlinear elements is to control the flow of current through it. That's why you can see the most of the linear elements are current controlled. Anyway, nonlinear elements are used as current source, current control, rectification, and frequency control applications. Active elements. The active elements are those which produces the electrical energy are called the active elements. Some of the examples are batteries, generator, transformer, operational amplifiers, etc. So any voltage source, current source present in a given circuit is the example of active element. So here if we consider this circuit, here the voltage source can supply the power to the resistor. It can supply the current to the resistor. So the voltage source is the example of active element. Any voltage source, battery, current source, generator, transformer, op-amp, these are the example of active elements. And what is passive elements? Passive elements are those which can't supply current, or it can supply the energy to the other element present in the given circuit. Rather, it consumes the power or energy by the energy supplied by the active elements. So here resistor can supply the voltage or current to the other elements. Rather, it consumes the power supplied by any voltage source or current source. So resistor, inductor, capacitor, these are the examples of passive elements. Now we'll discuss with unilateral elements. Unilateral elements are those which will allow to conduct current only single direction. So if we see this circuit here, this is the voltage source where the current can flow through the circuit when this is a diode and resistor are in series. If we close the switch 1, then the current will pass from the positive terminal of the battery and through the diode, and it will end at the negative terminal. But if we close the switch 2, then because the positive terminal is in the right side, so the current will not flow through the diode, because diode will not allow to conduct current if the cathode side of the diode having the higher potential than the anode. So this is the example of nonlinear elements. This is the example of bilateral elements. In this given figure, diode is present and connected in series with a resistor. If we turn on the switch 1, then the current can flow through the diode because the positive terminal is connected across the anode side of the diode and cathode is connected with the negative terminal of the voltage source. But if we turn on the switch 2, then the current can't flow through the diode because the cathode is connected with the positive terminal and anode is connected with the negative terminal. So it will not allow to conduct current. So the diode is the example of unilateral element. But in the second circuit, here the resistor can allow to conduct current both the direction if we change the polarity of the voltage source. If we fix the voltage source making the positive terminal in the left side, the amount of current starts to flow through the resistor, and if we reverse the polarity of the voltage source making the positive terminal in the right side, the same amount of current will flow through the resistor if the resistor magnitude and the voltage source magnitude are kept constant. So the resistor, inductor, capacitor, these are the examples of bilateral element. Network. An electrical network presence of an open path. Unilateral element are those which allows to conduct current only in a definite direction, only single direction. If we see the picture, first picture here, the diode is connected in series with a resistor and one voltage source. If we turn on the switch 1, the positive terminal of the voltage source is connected across the anode terminal of the diode and negative terminal of the diode voltage source is connected with the cathode terminal of the diode. So the current can flow through the diode easily. But if we turn on the switch 2, as the positive terminal is connected across the cathode terminal of the diode and negative terminal is connected across the anode side of the diode, it will not allow to conduct current. So this is the example of unilateral element. And another examples are transistor, or you can see the other power electronic elements which acts as a unilateral element. Bilateral elements. Bilateral elements are those which allows to conduct current both the direction if the polarity of the voltage source, if it is changed, then also the same magnitude of current it will allow to conduct. Here in the second figure, the resistor is connected across a voltage source. So the current can flow through the resistor left to right because of this arrangement. If we reverse the polarity of the voltage source, the current will flow through the resistor with same magnitude if the resistance value and the battery cell voltage are same. So the resistor, inductor, capacitors, these are the example of bilateral elements. Now we'll discuss network. An electrical network means this is the combination of different electrical elements. Here, the number of electrical components are connected, and the circuit means also this is the combination of different electrical elements. So what is the difference between circuit and network? In a circuit, there should be a closed path and the current will flow through all the elements present in the given network or circuit. And in electrical network, there should not, it will not form a closed path, and the current conduction through all the elements are not required. So we may say all the electrical networks are the circuit, but all the circuits are the network, but all networks are not circuit. Network. In an electrical network, there is a chance of presence of open path. If we see the figure here, the left side and right sides are open. And it is the connection of number of electrical elements in different fashion. And circuit means it is also the combination of different electrical elements, but it should form a closed path and the current will flow through all the elements. But in network, it is not necessary to conduct current through all the elements, and it will not form a closed path. So we can say all the electrical circuits are network, but all the networks are not the electrical circuit. Now we'll discuss what is the difference between node and junction. Node is a point in a circuit where two or more circuit elements or branches are connected. So voltage source V1 and R1 are joined together here. R1, R2, R3 are joined together here. R2, V2 joined together here. And V1, V2 and R3 are joined together here. So all the points are the node. But what is junction? Junction is a point where three or more electric circuits paths are connected together and where the current can split and flow in multiple directions. So this is the junction. You see the current generated by voltage source V1 will flow through R1, and at this point the current will go into different direction. So this is the junction where the current division will take place. Again, this is the point. The current generated by voltage source V2 will come out from upward direction, and it will flow through this point, and it will go through the resistance R2. The same current will flow through V2 and R2. So this is not the junction. Current is not dividing here. So this is the node. But here, after coming at this point, the current has two paths. One current can go this side and other current can go this side. So this is the junction. So again, at this point, the current coming from voltage source V1, one path is coming this side, other current is coming from this side. Both are joining together and again splitting. The I1 is going back to V1 and I2 is going back to V2. So this is the junction. So what we have seen, any points, intersection point of two or more elements are called the nodes, but every nodes are not the junction. When we do the nodal analysis, basically we are considering the junctions. So the potential of this node is considered as V1, as no current division taking place, and this point we are considering as a reference point. This is also named as the datum node or reference node, which has the ground potential or zero potential. So considering this node is considered as potential with V1. Branch. This is the part of a network, and this branch is present between two nodes. So here in between these two nodes, one element is present. Basically, this is the representation of a single circuit element. This is also another branch. This is the branch. This is the branch. This is also branch. But between these two nodes, as there is no element, so you can't say this straight line is a branch. This is not a branch because there is no element is present. So if any element is present in a given network or circuit, so the path between two nodes is called the branch. Loop. A closed path of a network is called loop. A loop is formed from a node passing through a set of nodes and returning to the starting node without passing the same node more than once. So here loop, if we see this circuit, then this is one loop, this is another loop, because if we start from A, then through 5 ohm, then B, then 4 ohm, again 10 voltage source to reaching at the same starting node A. So this is a loop. Again, if we start from B, then 3 ohm, then C, then 2 ampere, and through D, and again through 4 ohm, finally we are reaching at the starting node. So the all red colors are the loop. And if we see the dotted blue colored line, this is also a loop. This is the another path, A to B, then C, then D. Again, we are reaching at A. So this is also a loop. But what is mesh? Mesh is a closed path in a circuit which does not contain any other closed path inside it. This is most elementary form of a loop. So the red curve, these are the loop. This is the most elementary, and within this there is no any other loop is present. But within the blue loop, there is two loops are present. Those are these two red curves or red loops. So all the meshes are the loop, but all loops are not the mesh. So mesh means the elementary path, closed path of a circuit. Next, we will discuss with lumped network. What is that? An electrical element that is assumed to be concentrated in one place or located in smaller space in a circuit is said to be known as lumped element. Lumped elements can be physically separated from the circuit for analysis purpose. Example, resistance, inductance, and capacitance. If we see the first figure, in this figure, the resistance is specified within this portion, inductor is specified within this portion, the capacitance or capacitance of capacitor is specified within this portion. So if we see the physical circuit of this, then if required, we can remove it. We can remove any element, resistance, inductance, capacitance. We can remove from the circuit, or we can replace the element by other elements. So these are the lumped elements. And if the lumped elements present in any network, that is called the lumped network. Distributed network. Its name implies that the network where the resistance, inductance, capacitance are distributed. Something is distributed. What are those? The resistance, inductance, capacitance, these properties are distributed throughout the network. So if the example is the transmission line or distribution line. Here, in every transmission line having the resistance, inductance, and with respect to ground, there is the capacitance effect. So these resistance, you can't say within a particular portion or particular uh, segment is present. It is distributed throughout the line. Inductance property is also like that. And the capacitance is generated with respect to ground. So these are not physically separable from the transmission line or the distribution line. And the mathematical calculation for analysis, the element or parameter, it is long. But here in lumped network, the mathematical calculation or analysis is more easier than the distributed network. Hope you understand the different kind of electrical elements. Thank you.